Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next problem on multiple integrations type 1. So this is our question, and here if you see we have three integrations. So this is a problem of triple integration. So now in any problem of multiple integration we first write the variables. So our variables are x, y and z, and then we will write what are these limits for. Okay, so if you see here we have the variable x and here we have the variable y. So these two variables are present in the limit. So this limit are of the third variable, that is z. So these limits are for z equal to 0 and z equal to this term. So limits of z are done. Then we have x here. So we have the limits of x. So this limit has to be of opposite variable, and only variable which is remaining here, it is y. So this limits are for y equal to 0 and y equal to x. And what is the third variable remaining? So this is the limit of x equal to 0 and x equal to 1. So now if you see here we have written all the limits. So first, what to integrate? Everyone should think, what should we integrate first? Should we integrate first x, or should we integrate first y, or we should integrate z first? Why? So let's say we have our function, say integration of, I am writing some other integration, that is x equal to 0 to x equal to 1, y equal to 0 to y equal to x, z equal to 0 to z equal to xy. Okay, so I have this some other integration, and here we have only variable x. So now when I first integrate with respect to x, because x only has constant, it does not have any variable. As you can see here, y has some variable, z also have some variable, x do not have any variable. So this is very simple integration. So I will first integrate with respect to x. So this is the variable of x. So when I integrate with respect to x, so I will get x square upon 2, and here I will write the limits, and these limits will remain as it is. So it will be 1 square upon 2 minus 0. So this will be half. Okay, then I integrate with respect to y. We do not have any y variable, so it is nothing but integration of only y. So when I integrate with respect to y, I will get y, because integration of 1 is y, 0 into x, and limit of z will remain as it is. So when I put here upper and lower limit, I will get x minus 0, which is nothing but x, and here we have half. So now if you see here, we got the variable x again. So we cannot integrate x first, we have to integrate y first. But again, when we solve this z integration, we will get xy as some variable. So we get again y variable, so we cannot integrate y first, we have to integrate z first, then we will integrate with respect to y, then we will integrate with respect to x. So this you have to figure out which variable to integrate first. So shortcut here to remember the term, that is z has many variables, so we should integrate z first. Then y has only one variable, so we should integrate it second. X do not have any variable, so we will integrate it third. Okay, so depending upon the variable, you can decide which integration to integrate first. So first we will integrate with respect to z. So limits of x and y will remain as it is. So x equal to 0, x equal to 1, y equal to 0, y equal to root of 1 minus x square, and dx will remain as it is because we are integrating with respect to z. So dz 1 upon, when we are integrating with respect to z, x and y will remain constant. So we will group all the constant together. So we will have 1 minus x square minus y square. This whole term is constant minus z square, and integration of this term. So we are concentrating only on this integration. So here if you see, this integration is matching with one of our formula. What is that? Our formula states that 1 upon root of a square minus x square, integration of this is nothing but sine inverse of the variable upon the root of constant. Okay, so same formula, this term is matching with this term. Instead of a square constant, we have this constant, and our variable is z. So this integration will be sine inverse of variable is z, root of constant. So this is constant, and root of this term is 1 minus x square minus y square, and here we apply the lower limit of z, which is 0, and upper limit of z, that is root of 1 minus x square minus y square, and all these terms will remain as it is.